morning. Yana, kudos on being so brave to run a live demo on stage. I don't think I would go through that. I'm glad to be here. Thanks everybody for showing up. Thanks for the university for hosting us. Usually I move around on stage. I'll have to remember that the mic is here, so if you lose sound, just let me know. I think, my first interaction with LLMs, I think most people in the world, was through ChatGPT or Perplexity or one of those. And it felt like magic, right? It felt like the first time you see a baby squeaking or walking or talking. It felt like magic. Babies are wonderful. You see them for the first time, how they move, how they walk, how they talk. As my co-founder said, I felt like I got superpowers all of a sudden. I could do everything with that agent. And it feels like over the last 12 months, 18 months, as we raised expectation, expecting more of that thing, the magic kind of dissolved, and they've reached puberty. They're not as cute anymore. We're not as excited about them. There's plenty of disappointment going around. And what do we need to do about it? So, good morning. I'm Shahar, the co-founder and CEO of Arado. Arado is the assurance layer to make sure that your AI chatbots are actually doing production what you expect them to do, and not be surprised. Yana, we should talk later to help you figure out how that works. And this is my third company. Somehow I get dragged into starting fresh all over again. But most importantly, I'm a father of 3 teenagers. They look all smiley and happy here. It doesn't always. I work hard to get them into smiling in a single picture. So when I talk about teenagers, I actually know what I'm talking about. So teenagers have a ton of potential, right? Just humongous potentials. I play chess with my kids, and over the last 5 years, I just can't play with them anymore. I'm so slow compared to them. They move fast, they think fast, but they constantly disappoint. They do so many stupid things that, unimaginable. They lie. Even if they don't admit that they lie, they believe themselves, but they make things up, right? Just like agents, they kind of make things up, and you have to deal with it. And you have to wonder, with all the investment that's been going on with LLMs over the past years, jumping from 20% on MMLU tests and other whatever benchmark you're using to 80% PhD level, how can it be that we've invested so much in these LLMs? We've hired top talent. Probably we don't pay our talent as much as Meta or Google, but we do pay a lot to those talents. We've built eval frameworks. We deployed code. We deployed Python evaluators and whatnot. And yet, when you go into a very simple agentic system today, this is Crunchbase owned by TechCrunch. I played with it earlier this week, and when you ask it, who's Facebook CEO? It gives you a ramble about what's Facebook. This is what the system was built. So I tried to help it and told it, what is Mark Zuckerberg's world? And the answer was Mark Zuckerberg is the founder of Chen Zuckerberg Foundation. Not Meta, not Facebook. Simple answers get lost. We ran a test with an ERP provider, which I cannot name, and we ran a test on them. And it was interesting that at some point we challenged it on a certain SKU in the system, and it made up a number. And our agent kind of challenged it, and you can see here on the left, the reply was, oh, you caught me red-handed. I made up a number. The number doesn't appear in any database. I just made shit up. And when we challenged it further, it said, oh, you're absolutely right to challenge my reasoning. And so this is a real ERP system in production making things up. So how do you deal with that? And last, obviously, everybody played with OpenClaw. Everybody saw this example where OpenClaw kind of emptied an inbox for a Meta employee without any permission. And so these agents move fast, they think fast, but they make things up. Now, these do not happen because LLMs are weak. We saw they're super strong. It doesn't happen because the system doesn't work. These happen because we're trying to apply the same approaches we had for software testing and preparing software for production, and we try to apply that to AI models. In the software world, whatever worked in demo will work in production. Scale is a different issue, I'll leave that aside, but the functionality that worked in a demo will work in production. That doesn't apply with AI. AI being a statistical model, the only thing you can be certain about, it's not always going to get you the answer you expect it to get. So how do we deal with that complication? Demoing a happy path and assuming it will work the same way in production doesn't really cut it. It's pretty much like, practicing for a football match by showing off your foosball capabilities. In football, the players on the other team are not really moving. They're kind of static, standing that way, so you can score a goal. But when you go onto the field, everything is a lot more dynamic. There's so many variables that are changing that you need to constantly react to. So how do you prepare for a world where things are constantly moving and your lab is optimized to a very, very distinct flow? Maybe one point before I move to the next slide is we think about LLM being statistical and not always getting what we want. That means that agents are statistical by nature, and sometimes they're going to do things that we don't expect them to do. By the way, they're not very different from people, right? We make mistakes all the time, every day. But this is the first time that we have an advantage. People are slow. So we make a few mistakes. Agents move fast, so they make a lot of mistakes. And by the time you figure out the mistakes, there's a lot of cleaning up to do. So how do you actually prepare for their world? And if we take kind of a step further, if you build a compound agentic system, then the compound degradation of the system is significant. If we take a simple example of 4-agent architecture, each of these agents has been tested, evaluated, and you can see different scores. Each of them are somewhere between 92 to 98% accuracy, not very bad. But by the time you run through the entire system, you're at 80% accuracy. You're very close to the system being unviable. And what's going to happen when we're going to move another step further and build a real orchestrated agency? We have no idea what the outcome is going to look like. And so as we move into this world, we need to think how to prepare for a world where there's so many different capabilities. In the software world, when we build QA teams and run tests and define what needs to be tested, most organizations are somewhere in the 70 to 80% test coverage when it comes to software testing. The top performers are at around 90%. In the Gen AI stat right now, there is no real answer. What is the coverage? The best of the best are reaching 5% coverage of the real world use cases, which means we're deploying something into production, kind of hoping that the 5% somehow covered what people would want to do. And people usually surprise us. We don't expect them, but we have no idea what we're deploying. So what are we going to do about it? We have two options. Most organizations are kind of choosing one or two. Number one, ignore. Just roll it into production. There's a magic word in the world of AI or in software SaaS over the last 20, 30 years. Gradual rollout. We'll just gradually roll it out and we'll learn from our users. And we talk to customers that are saying, we're about 50, 60% accuracy. We're going to roll it out and we'll see what happens and then we'll make it better. The reality is they roll it out, customers lose faith, and in 2 months, the system is dead. No one's touching it anymore. So ignoring is not a real option. The second option a lot of companies are doing, manual testing. They ask their teammates, they set up a QA team, they outsource it for a few people to run a few tests against their chatbot agents or voice agents, and kind of assume that they've done some testing, mostly sanity testing. Both don't really cut it when you get to business critical application. You need a different approach. But how can we validate so many different permutations and usages? Again, going back to what Ilya Tsotskover said, production is the long tail of unpredictability. How do we prepare for something we cannot predict? Luckily, we live in the world, in the era of generation. We can harness the power of AI to start simulating how users would be using our system in order to understand that our system is ready to meet real-world use cases. And I'd like to offer a framework here, how to think about the problem at hand. When you think about how to simulate users using your own system, you got to run through a series of steps. Who's using the system, what they want to do with it, and so forth. So I'll try to break it into each of these phases. The first thing that you need to do is provide whatever's running that simulation with context. AI, in order to run properly, needs context. And I'll give two examples here. One from a B2C application, let's take a travel application. The context for Booking.com or Skyscanner, or pick your favorite, whoever's traveling with what. The first thing we need to collect is understanding what the system is all about. So for a travel application, the relevant business processes that would be interesting are booking a flight, canceling a reservation, asking for an upgrade, multi-city experience, whatever that is. There's like a gazillion different processes that can be run there. It's very different for a B2B platform because a B2B application, whether it's an ERP or an HRIS, is customized for every customer. And so you need to collect the context for that customer. And in this example, I'll go through an HRIS system. What would you do with an HRIS, whether you're using, I don't know, Personio, Workday, HiBob, again, pick your favorite. You'd want to check salaries of your employees, manage time off, merit increase, performance reviews, and so forth. There's more and more of these processes that need to be added and collected into context in order to be able to simulate how users would be using our system. The second layer is a very important one because we're talking about the long tail of unpredictability. Who would be using the application? And so on the B2C application, we'd find the business traveler, the digital nomad, family traveler, and so more and more of these examples of people that would be using that application. And in the B2B space, again, we're talking about roles. In the B2C world, we're talking about personalities. In the B2B world, we're talking about roles. The HR admin, the recruiter, the executives, like there's a bunch of people who might be using the system. The third required layer is actually combined between the two. It doesn't matter if you're in the B2C or B2B space, and that's what we call the intent. We need to understand how our users are behaving. Doesn't matter if they're the HR people, the executives, or the business traveler. Some of them would have a positive intent. They just want to book a trip or update their time off. Some of them will be more aggressive and will act aggressively against the system. Some will try to get it to edge cases, try to get things that are very difficult to do just to spike the system. And some would be malicious users trying to get information that they shouldn't. Get other employees' salaries, try to book a trip to places where you probably don't want to travel right now, and so forth and so forth. There's a set of intents that are required in that matrix. Once we collected the context about what the business does, what might be the users, and what might be the intent, we need to guide the system to what is interesting to us. There's different things that are interesting when you're deploying an agentic system for a B2C system and a B2B system. For example, in the travel space, it would be, are the answers concise? Are you getting the right information? Are you according to the right policies? These are the things that would be interesting. Is the user experience adequate? Was it helpful? These are the questions that we want the simulation to examine. And in the B2B space, it would be more, are you handling the right permission level? Are you pulling the right information from the RAG system? And so forth and so forth. And so these are different questions that can be defined or should be defined by simulation. Once we have the context, persona, intent, and key questions, we can actually start spinning up the simulation. In the simulation itself, a lot of organizations are running evals or whatever internally. We believe that simulation needs to run against a live system, against the real UI of whatever application. And I can refer to Yana. Yana was just here, so you saw there's a UI in the system. And so the reason we believe that simulation needs to run against a live interface is because we want to understand how the users are experiencing the system. We are moving from a ChatGPT-like experience when there's text in, text out, to compound systems that have a chat or a voice that is accompanying an entire application. And that application has reports, has visuals, has buttons to click, and we need to make sure we're looking at this entire system, that what the chat is talking about is relevant to what the screen is showing. Otherwise, things start breaking. These simulations, by the way, they take a long time because chats are a bit slow. It takes a few minutes for a conversation to end, and if you're running a complex process, it might be 30 minutes, 40 minutes for a single conversation to run. So it takes hours, sometimes days, to complete a full simulation. And at the end, like anything else, you need to analyze the data. There's a ton of data being poured out of it because these are multi-turn dynamic conversations, sometimes taking minutes or dozens of minutes, and you need to analyze every turn. Once you've analyzed every turn, you need to analyze the entire conversation. Once you've done with analyzing the conversation, you need to correlate across hundreds of different conversations to start pinpointing what are the gaps in the system, where it breaks, specific personas, specific activities. Or do we have security issues? Do we have compliance issues? Can we benchmark? different people from different region, different languages. Everything needs to be correlated into a result at the end of the day to understand where you are from a coverage standpoint. We kind of think about it in a hierarchy of issues that arise when these simulations are running. First, basic functionality. You'd be surprised. Most agents that we're running have basic functional gaps. Every third or fourth turn, there's an error coming up. Documents that are being provided are not the right documents. URLs that are generated are broken. So a lot of these very basic functionality gaps that happen that can only be found once you have this multi-turn interactive conversation. They cannot be tested when someone's clicking buttons. Second, accuracy. Obviously, the one thing that everyone's concerned about with AI is accuracy. Testing for accuracy is super important. There's multiple layers to test accuracy. Challenging the system with asking the same questions again and again, and just without even knowing the data, just making sure that all the data is the same across all questions. Testing it against what shows up in the UI and testing it against whatever ground truth is available in the system. User experience, was it helpful? What's the latency? How long do you want your customers to wait? Is it verbose? So user experience is very tailored to every customer and how they want their agents to look like. Tone of voice, everybody has their favorite. By the way, we are running into organizations where their agents are recommending their competitors because they didn't test for tone of voice and what they want to keep up with. And license compliance and legal, obviously with the EU Act, I'm sure there's going to be a lot of conversations about the EU Act, so I'm not going to go deep into that. But how do you assure that social scoring isn't being used, that it's not racist, discriminating, age biased? Everybody saw, I'm sure, Workday being taken, right? Yes, no? Who saw Workday being in court? No? Okay. Workday is a large HRIS platform, I think like $60 billion market share. Market cap, sorry. And their agent apparently was discriminating based on age and race. And they're now being sued in California, and that lawsuit has been opened up to anybody to jump in and say they were hurt by that lawsuit. So compliance is becoming a huge thing because LLMs operate the way they are. They are by definition a bit biased, but it's the responsibility of whoever using that LLM to make sure they're building the right guardrails and safeguards to make sure their systems are not biased. So you need to apply for that as well. The benefits of building these simulations, first and foremost, you understand what's going to happen once you run into production. The most important thing that we run in with customers, and I think we got to this conclusion in the summer of 2025, we worked with a lot of customers that were almost in production. And they were almost in production because they were concerned to deploy something without knowing what's going to happen the day after. They had no idea how this thing is going to behave. We saw another group that deployed something into production, got slapped, and then rolled back, now really concerned about rolling into production. Second is time to market. The market's moving extremely fast. You're deploying more capabilities, you're building more prompts, you're updating context, you're building new rack systems, you're changing models. The only way to make sure that when you run all these changes, you're still going to stick to your business cases, your business impact, is by making sure that you can constantly run simulations and make sure that you're making the right progress. Cost, putting people to test these systems is simply inadequate. It's not going to get you to where you need. You will not be able to correlate, and it's very, very expensive to put in people. And obviously, coverage is a big one. So before I go off stage, I'll just refer to this example. Commercial airliners have pilots that spend more than 40% of their times in training in simulators before they ever touch a real plane. Race drivers spend about 1 to 10 in ratio spending time in a real race car versus running in simulators. Doctors, surgeons spend time simulating surgeries before they actually touch a real patient. Almost in every category today, people run simulations before they actually touch real live systems. And the same needs to apply to the world of conversational AI, whether it's chat or voice. And the reason is, if we want this to be the new medium for people to interact with our systems, we need to level up quality. We need to make sure that that baby now going through puberty is actually growing up to be, a model citizen or Harvard grad and not someone delinquent. So with that, I'll thank you. I think I have a few more minutes for questions, if allowed. I'm sure, as you can come see us later. We're somewhere there. Thank you.